Okay, so when we're asked to find the inverse, though, we're not going to want to always do it graphically. We're going to want to do it algebraically as well. So let's do this second example algebraically. We're going to find the inverse of the function 3x minus 2. So I'll do each of these step by step, and we'll write down the steps, and then we'll try it a couple times. So the first thing we want to recognize is f of x equals 3x minus 2 is the same as y equals 3x minus 2. So, of course, it's the same thing. We're just changing it to y equals because to find the inverse, of course, we need to switch the x's and y's. So step 1, sub y equals f of x. Okay, instead of saying f of x, let's call it y. So it's y equals instead of f of x equals. Okay, so that's step 1. Step 2 is actually taking the inverse. So switch x and y. So wherever you see an x, you're going to replace it with a y. Wherever you see it with a y, you're going to replace it with an x. So here it goes, x equals 3y minus 2. This technically is the equation of the inverse, but we don't like to see equations written this way. We don't want x equals, we want y equals. So then all that's left now is to rearrange so that y equals. So step 3 is to rearrange for your new y equals, because that's the equation of the inverse, the new function. So I'd like y equals, so I'm going to take the 3y that's here, bring it to the other side, so it's minus 3x. The x that's here, I'm going to switch to the other side, so it's minus x, and the minus 2 stays there because it's already on the correct side. Of course, I don't like the fact that I've got a negative, so I'm going to divide everything by negative 1. Dividing everything by negative 1 makes this a positive, and this a positive as well. So that's just dividing everything by negative 1. And of course, I want y equals, not 3y, so I'm going to divide everything by 3. And so we'll lay left y equals x over 3 plus 2 over 3. Or you could have x plus 2 over 3, the whole thing. Either of these would be fine. The last step, and it's important, especially in this question, is there we've got the equation, but now our step 4 is to sub the negative, the notation, the f at negative x notation in for y. Because if you look back at the question said find this. So we just simply finish by saying instead of the y, we're now saying, okay, this is the equation of the inverse, so I use this notation, and x plus 2 over 3. And that's the equation of the inverse. Don't forget that last step. I'd hate for you to do all the math correct and then at the end forget to actually answer the question, which was to sub in f at negative 1 of x. Okay, and just replace your answer with that. And there's the inverse. So those are the steps. So let's try it back with the first example. So we know what the picture was in that first example, the parabola that was moved up 4. Now I'd like you to do it algebraically to find out what the equation of that inverse is. So we'll remember the steps. First things first, we'll go y equals x squared plus 4. And then you notice I draw that line because this is the spot where I'm going to actually take the inverse. I don't want anyone to think that the two equations are exactly the same because they're underneath each other. So I just draw that line because this is where I take the inverse. X equals y squared plus 4. Okay. These two equations are not equal. That's why I've drawn that line to separate it. Say, okay, this is where I'm going to take the inverse. Okay, so I've done step 1, replaced y equals. Step 2 is I've switched the x's and y's. And now I got to do step 3 and rearrange for y. So again, it doesn't matter which side. I could leave the y squared over here, which might be a little bit easier because it'll stay positive. The x is here, so it'll stay x, and the plus 4 would become minus 4. But again, I don't want y squared, I want y by itself. So I have to do the inverse operation. The inverse operation to squaring is the square root. And so it ends up being the square root of x minus 4 equals y. And it's very tempting to say that our answer is done. But if we stop and think about it, or actually, we're not quite finished. I know we still have to put in f at x, I know we still have to do this part, but there's something else in the line before that I'm missing. And I know some of you have taken the course before will know this, probably you're screaming at the screen to tell us, but let's just stop and think about it. If we actually graphed that function, if we graph this right here, we would get, well, it's a root function and it's moved to the right 4. Okay? So there's what that graph would look like. If we go back a couple of slides, we remember that we actually have both halves of this. We have this parabola. So how come algebraically it produces this? Well, the one thing we have to remember that we often forget and usually ignore, when you take the square root of a number, there is a positive answer and a minus answer. So when we take the square root here, we have to have plus and minus. So the answer is plus minus the square root of x minus 4. Graphically then, the positive x minus 4 is this top part. The negative would be flipped like that, and you have both the positive and the minus, which is what we needed to satisfy our picture. So just remember, when you take the square root of something, in this particular case, remember that there are two answers, a positive answer and a negative answer. And then now that looks like the graph that we had done before. We'll do another example here. Different function then. This function is f at x equals 1 over 1 minus x. So this is a rational function. Let's try the algebraic steps for this to get the inverse. So y equals 1 over 1 minus x. That's step 1. Step 2, we switch our x's and y's. So x equals 1 over 1 minus y. Now the challenge in this one is to isolate for y. And it's why I've chosen this example so you can see it. So to isolate for y, I need y by itself. Since it's at the bottom of a fraction, I'm going to try and bring it up to the top. So I'm going to take this whole thing and try and bring it up here. To do that, I have to do the opposite operation, which is to multiply. So it's x, which is here already, times 1 minus y. I've done the opposite operation. That leaves me just a 1 over here. And now, I'd like the y by itself. So I've got this x sitting here. I need to get rid of it, so I got to do its opposite operation. So we'll get this. 1 minus y is now by itself. And we divide it by x, so it's 1 over x. Trying to again isolate for y. I'm going to leave the minus y here. I'm going to move that 1. So when it comes across, it's minus 1. And then I'm going to divide everything by negative 1. So y equals negative 1 over x plus 1. And I'll finish with f at negative x equals negative 1 over x plus 1. And that is the inverse.